Right. So, you've seen half of all of the kinds of parabolas out there. Okay? You've dealt with them in Algebra 2 and in Algebra 1. Okay? Now, in both Algebra 2 and Algebra 1, you only did y equals x squared parabolas. Okay? And those were parabolas that had an opening that was up. We called them U's. Or we had opening down parabolas, which we called like humps. Okay? Alright? So we had U's and humps. Now, this chapter, we're going to expand that knowledge to x equals y squared parabolas. Those are parabolas that open to the left and open to the right. Okay? The nice thing about conic sections and teaching things the conic way is that all of the formulas and all of the procedures, if you will, all of those are the same, no matter what. If it opens up, right, down, or left. Okay? You're going to follow the same steps all the way through. Okay? So, what my plan for today is I would like to develop the 5 steps to graphing a parabola. Okay? In order to do that, we have to talk about what a parabola is, because the 2 parts that make up a parabola are important in the steps. Okay? So, the definition of a parabola is all points equidistant from a point called the focus and a line called the directrix. Okay? So the focus is a point that is located inside the parabola on something called the axis of symmetry. Now you've seen axis of symmetry back in Algebra 2. Okay? So it's on that symmetric line, okay? Which for us is either going to be a vertical line or a horizontal line, depending upon which way our parabola is open. The directrix is a line outside the parabola perpendicular to that axis of symmetry. Okay? So if my axis of symmetry is vertical, my directrix is horizontal. If my directrix is vertical, my axis of symmetry then is horizontal. Okay? So, first, so what I'm saying about that is, so if I draw in a parabola, okay? So there is my parabola. What it's saying, and I didn't do a very good job of drawing it, but what it's saying is the distance here is the same as the distance there. I did a really bad job of drawing it, actually. Okay? So let's just start over on that one. We'll just go like that. So I need to come in about here. That looks a lot better. Okay? So this distance here is the same as that distance there. This distance over here is the same as that distance there. Okay? Anywhere on this parabola, those are the same. Okay? The distance to the point and to the line are the same. Okay? That's what makes a parabola a parabola. Okay? We're going to call P the distance from the vertex to the focus and from the vertex to the directrix. So P, orange, so this distance from my vertex to my directrix is the same 1, 2, 3, and 1, 2, 3, and 4 right there. As right there. So the focus is right there. Okay. 4p comes into play because it's the coefficient on the non-squared term. The non-squared variable is 4p. But we'll see that momentarily. Okay. So P is the distance vertex to focus or vertex to directrix. So we could call the vertex the what between the focus and the directrix? Midpoint. Okay? So the vertex is the midpoint between the focus and the directrix. Okay? So, step number 1 says you need to determine which way the graph opens. Okay? If the square, and you determine that by looking at which term is squared. If it's an x squared equation, your parabola is going to open up or down. If it is a y squared equation, your parabola is going to open left or right. Remember that the number here in front of the non-squared term is 4p. Okay? That number is 4 times p. If that number is positive, your parabola is either going to open up or right, the two positive directions. If we're going up and down, up is the positive direction. If we're going left and right, right is the positive direction. Okay? If that number is negative, it's going to open down or left. So this number right here is positive. I have an x squared, so therefore it opens up. This number right here is negative. I have a y squared, so it's going to open left. That's the first step in graphing. And it's extremely important because it's going to tell you which way your direction is opening and which, you know what I mean? And from there, then, it's going to determine the remaining steps. Okay? Which direction you go with the remaining steps. Any questions on step number 1? two things. Which variable is squared? Positive or negative on the non-squared variable. Okay? So, step number 2, we need to identify the vertex. Okay? And we need to remember that anytime we are dealing with a set of parentheses, we think oppositely. Okay? So, first off, step number 1 on this one, which way does this parabola open? I've heard up, down, left, right. I've also heard just down. Which way does it open? It should only be one word. Down? That's your guess. Okay? What are the two things that we have to look for? Which one is squared? X is squared, right? So when x is squared, that narrows it down to up or down. Okay? 4p, positive or negative? Negative, so that makes it down. Okay? So this one, this little side note action here, this one opens down. Okay? Alright? So the vertex then is going to be the number attached to the x and the number attached to the y. So I'm looking at this number and I'm looking at that number. Are both in a set of parentheses? Yes. So I have to think oppositely, correct? Okay. Well, what's the opposite of the left one? It looks like -3, right? What's the opposite? +3. So my vertex is at 3, comma, -1, because it looks like +1, but it's in a set of parentheses, so I think oppositely. You've done that before. You've done a lot of that stuff back in Algebra 2. Okay? Now, I get it. I'm asking you to remember stuff from over a year ago. Okay? But we did in Algebra 2, we did like 6 weeks on that stuff. So, okay? B. Tell me which way it opens. Tell me what the vertex is for B and C. Tell me opening and vertex. Opening of B. Up, down, left, right. Agree with up. Okay? The squared term is x, so that's up or down. 4p is positive, so that just leaves me with up. Okay? Vertex. Where is the vertex? What you got, Jake? 1, 0? Do we agree with 1, 0? Yeah. Think oppositely of the x, and that's going to be +1. There's nothing attached to the y, so we say 0 for nothing in math. Okay. C. Up, down, left, right for my opening. Right? Because the y is squared now, so that's left or right. 4p is positive, so that leaves me with right. Okay? Vertex. -2, comma, -7. Okay? The kicker here is the x1 is over on that side now. Okay? It doesn't work left to right. It works what's attached to the x and what's attached to the y. So positive 2, I think oppositely is negative 2. Positive 7, I think oppositely is negative 7. Okay? Any questions on step number 2? Identifying the vertex. Okay? Step 1, find which way it opens. Step 2, find the vertex. Okay? Step 3, then, is going to be finding that p-value. Okay? That p-value is the distance from the vertex to the focus. It's also the distance from the vertex to the directrix. Okay? Remember, this number right here is 4 times p. Because it's the coefficient of the non-squared term. So 4p is negative 12. So p is what? Technically it's negative 3, but p is a distance, right? So it's just 3. Okay? We can write it as negative 3. I don't care about that. Okay? But when we put it on the graph, we're going to use it as a distance. So then it's going to be a distance of 3, so it's positive 3. Okay? So now, step number 1 told us that our opening was down. Right? Because this was example A on the last slide. Okay? So we said it opened down. X is squared. 4p is negative. It's going to open down. Okay? Step 2 said that our vertex was at we said positive 3 comma negative 1, correct? So there's our vertex. Step 3 tells me that p, that distance, is 3. So now, because I'm opening down, 3 down from my vertex, 1, 2, and 3, is my focus. So where is the focus? 3 comma negative 4. What do you got? So just drop the negative.
Okay, I was in the middle of writing, so it kind of messed up.
Oh, okay. Okay. Yeah. P is the distance. Oh, let me back it up a little bit. P is the distance from the vertex to the focus.
Yeah.
So this distance right here, is P, which is 3. Okay? Then I can also find the directrix. Because which way is the directrix from my vertex? It's up. How far up? 3. 1, 2, 3. So this is also P. So what is the equation of my directrix? What you got? Y equals 2. Okay? Remember, horizontal lines are y equals, vertical lines are x equals. Okay? Questions on finding P? Why does p equal 3? Because this number in front here is, one more, 4p. The number in front of the non-squared variable is 4p. Okay? So in this particular case, negative 12 is 4p. So p then is 3. Okay? The distance then is 3. Really, p is negative 3, but distances we make positive. Okay? Is that what you're... Okay? Everybody else good? Sure?
This may be a bit weird, but what's the difference between the directrix and the asymptotes?
Asymptotes are a line that is kind of like a boundary. Okay? The directrix is part of the parabola, and it's, if I go way back, it's what the parabola is equidistant to. Okay? So like if I pick this point right here, okay, the distance from here to here, I'll call it 15. Okay? Then this distance right here, because distance perpendicular to a line, that distance is also 15. Okay? So it's not like an asymptote where my function is going to approach it as we go out to the ends. Okay? But it's part of it because this distance for every single point on that parabola is equal. Okay? We just draw it as a dashed line because technically it's not part of it, but it's how you make it. Okay? Now, the next thing is that 4p number is also what I like to call the width of the parabola through the focus. Okay? So you go to your focus and you go half of 4p in each direction. Okay? So let me bring us back up to speed here now. We said that 4p was negative 12, right? Okay. We had also said that our vertex was at 3, negative 1. Then we said that our focus was 3 away from that, right? And our directrix was 3 the other way from that. Yes? Okay. So all I did there now is I just recreated what we had done in step number 3. Okay? All right? Now, what step number 4 is saying that the width of my parabola, remember my parabola is opening down, it goes away from my directrix. Okay? The width of my parabola at the focus line. So at the focus, the width is 4p. 4p is 12, right? Okay. So my distance down here, we'll go with the distance on this horizontalness right there. That distance is 12, or that width is 12. So half of 12 is 6. So I'm going to go 6 to the left and 6 to the right. One, 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, and 6. Okay? So those are points that my parabola goes through. Because That's how wide the parabola is at that focus. So now what we can do is we can draw our parabola in. We have a downward opening parabola, correct? Okay, that was step number 1. We have a vertex at the point 3, -1. That was step number 2. That's right here. We have a P distance of 3, so that puts the focus 3 away, 1, 2, and 3. That puts the directrix 3 away, 1, 2, and 3. That was step 3. Step 4 said that our parabola is 12 wide through the focus. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We're 12 wide through the focus. There's our parabola. Okay. Step 5, then, is going to be, we can finish this off by just putting in the axis of symmetry. So, once again, here was our vertex. Here is our focus. Here is our directrix. Our parabola was 12 wide. 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, and 6. Ooh, she's bouncing today. Screen's bouncing. Okay. Our axis of symmetry is perpendicular to the directrix through the focus and the vertex. So what line goes through the focus and the vertex? X equals 3. Or simply, if it's an up-down parabola, it's x equals the x part of the vertex. If it's a left-right parabola, it's y equals the y part of the vertex. Okay? Or of the focus. Actually, no, I shouldn't say that. Yeah, I could say that. Because it's the x part of the focus.
Oh, okay.
Right?
I thought you were saying the...
No.
I got the...
Yep.
Stuff.
Okay? Now, tomorrow I'm going to give you a worksheet. Okay? On that worksheet, it's going to look, and it's hard for you guys to see this if you're listening on the line, but on that worksheet, it's going to have 9 graphing type problems. And then below each one of the graphing type problems is going to be a spot for you to put the vertex, a spot for you to put the focus, and a spot for you to put the directrix, and a spot for you to put the axis of symmetry. Okay? On the quiz that I am planning on giving next week, Thursday, there will be a spot for you to answer all 4 of those questions to go along with this graph. Okay? So the vertex here, and you have to answer them in order to get to it. This is step 2. Both of these are step 3. Our focus, we said, was at 3, -4. Our directrix, we said, was at y equals 2. Axis of symmetry is step 5. Okay. Monday, I told you that it's going to be extremely important for you to write these steps down and then transfer them to a note card. Okay? This is why. I'm going to break it down for you step by step. You do this first, you do this next, you do this then, this, and this, and you're done. Okay? And all of my questions are going to be, it's going to basically be step 1. I'm going to look at your graph and I'm going to know if you did step 1 right, because your graph opens down. I'm going to look at the vertex to see if you did step 2. I'm going to look at the focus and the directrix to see if you did step 3. Look at the graph to see if you did step 4. Look at the axis of symmetry to see if you did step 5. Okay? Right? Like I said, and I don't mean to belabor this, but this is easy stuff. I have broken it down for you into the simplest possible steps. Okay? You have to make the conscious effort now to follow. Okay? Right? You're seniors. I get it. But you know what? It's January 4th. So, you got time yet. Okay? No, we just came back from winter break.
Damn.
Yeah. Because wasn't, I gotta look now and see.
The week that we had
No.
I want
2
to say we
weeks.
got back
It
on
was
the
2
third.
week year.
We got back on the 2nd, right?
Oh, the second, yeah.
Yeah. Yeah.
This year was
So we're 1 day removed.
So we're one, yep, so it's January 3rd. Because it's the 2nd day. Yeah.
Oh yeah, we shouldn't be here if it's January 6th.
Right.
I'll go home.
Right. Okay?